Hello students, welcome back to my channel. Today we'll be discussing questions from units dimensions, kinematics and friction which were asked in the first half, that is morning session of 29th January 2023. So let's begin. So we have first question here. You can see list 1 has certain physical quantities and list 2 has the corresponding dimension formula. So we have to match that. Now again, I will repeat what I have already repeated. I have already told you in other videos that you are not supposed to match all the four quantities. Okay, you have to match only one or two, maximum two. I think. Guess. For example, you see here. Here you see A and B are same here in option 1 and 3. A and B have been matched in the same manner. Whereas in second and fourth, also A and B have been matched in the same manner. Similarly, C and D in first and third option have been interchanged and what you say as compared to second and fourth option. So it's a matter of finding A or B and C or D. That's all. That is enough. So let us first take this pressure gradient. So as you know, pressure gradient is basically drop in potential per unit length. It is usually referred to with reference to a pipe. For example, if a pipe carries a fluid, the fluid is flowing because of a pressure difference along its length. So pressure gradient will be change in pressure per unit length. So dimensionally change in pressure is equivalent to that of pressure, which is actually force by area multiplied by length. And length will be equivalent, change in length will be equivalent to length itself. So you have m l t power minus 2, area is l square and then again l. So one l gets cancelled here, we are left with m l power minus 2 t to the power minus 2. So m l power minus 2 t power minus 2 means this. So a should be mapped to 3. Then let us find out either C or D. Okay. We'll take up electric field probably. As you can see, electric field is the only physical quantity which involves charge, and charge is related to A because the dimension formula for charge is A into T, that is current into time. So C should be mapped to 4. So this way, just find it out which option has A mapped to 3 and C mapped to 4. You can see this is the option. This is the correct option, of course, but still we'll find out the dimension formula of energy density and latent heat so as to confirm this. Okay, then let us find out for energy density. Energy density is basically energy per unit volume. Usually we use the word density to denote per unit volume. Okay, but there could be linear charge density, charge per unit length, then there could be surface charge density, charge per unit surface, but usually density word is usually applicable for something per unit volume. So here it is, I'm sorry, per unit volume. So energy will be force into displacement upon volume. So force is mlt power minus 2, length is L, volume is L cube. So as you can see, 2L gets cancelled and finally we are left with mL power minus 1 t power minus 2. mL power minus 1 t power minus 2. So energy density should be mapped to 2 itself. So B should be mapped to 2. Latent heat is basically energy. Heat is after all a kind of energy, and for energy you know it is force into displacement. So force into displacement. No, latent heat. Basically, what it means is specific latent heat. And specific heat is actually heat required to bring about a change in state per unit mass. So basically, latent heat would mean heat, that is energy, per unit mass. So for energy, it is force into length on mass. So force is ml t power minus 2. Again, there is an L. M gets cancelled. So there is no M here. So latent heat should be mapped to 1. So finally, you have third option as the correct answer. Moving on to the next question. A tennis ball is dropped on to the floor from a height of 9.8 meters. It rebounds to a height of 5.0 meters. Ball comes in contact with the floor for 0.2 seconds. The average acceleration during contact is. As you know, the average acceleration is basically equal to the average rate of change of velocity. So average rate of change of velocity would mean change in velocity upon time taken. Okay, remember velocity is a vector quantity, so we have to be very careful. We need to subtract vectorially. So I'll take the final velocity as v, initial velocity as u upon delta t. Now here, suppose this is a floor. The ball strikes the floor with a certain velocity u and it rebounds with a certain velocity v. Okay. So if I take upward direction as positive, then downward direction will be negative. In other words, v will be positive and u will be negative. So therefore, what I can write is magnitude wise it is v minus u. That is, it is v plus u. Okay, then you know that if a particle is allowed to fall from a height h, the speed acquired is under root 2 gh. Similarly, if a particle rises to a height small h, the speed with which it rebounds is also equal to root 2 gh. Okay, let us calculate those values there. Root 2 g is 10, h is 9.8. So this is based, and here it is under root 2 into 10 into 5. This simply root 100 is 10 meters per second. So here we have, so 14 plus 10 upon 10.2 seconds. Okay. So this is 24 by 2 to 10. So 120. So 120 is the final answer. I hope that is clear. Then moving on to the next question. A stone is projected at 30 degrees to the horizontal. The ratio of kinetic energy of the stone at a point of projection to its kinetic energy at the highest point of light will be. So this way you have a projectile motion, the trajectory you can see. Let us say this is theta degrees. Okay, the ratio of kinetic energy at the point of projection. Suppose it is projected with the speed u, then the initial kinetic energy there will be half mu square, where m is the mass of the projectile. Then the kinetic energy at the highest point. Now at the highest point, you know, only the horizontal component remains. Vertical component has already vanished there. So here the final kinetic energy will be half mv square, which is half mu square cos square theta. So the required ratio will be initial kinetic energy is to final kinetic energy. So as you divide, you can see half mv square gets cancelled and you are left with cos square theta in the denominator. Okay, cos square theta in the denominator. So it is cos square 30 degrees. Cos 30 is root 3 by 2. So whole square is 4 is to 3. So this is the correct answer. Moving on to the next question. A car is moving on a horizontal curved road with radius 50 meters. The approximate maximum speed of car will be if friction between tires and road is. So suppose this is the car, the top view. It is going along a circular track of radius r with a speed v. Then you know that the required centripetal force will be provided by the friction. So friction is providing the required centripetal force, and as you know that if we have to limit the speed, then the car should be on the verge of slipping, on the verge of sliding. So if that be the case, then the friction has to be limiting friction, and limiting friction will be mu into normal reaction. Considering the vertical equilibrium, we can write n equal to mg. If we consider the vertical equilibrium of the vehicle, so mu into mg will be equal to mv square by r. So from here, we can get the expression for maximum speed. M gets cancelled. So maximum speed will be under root mu g r. You have to memorize this result and result, so that straight away you can apply this formula. So coming to this situation, V max will be under root mu. What is mu? Frictional coefficient is 34 by 100. Then G they have given as 10. Even if they don't give, you have to take it as 10 itself, so that you are able to calculate it quickly. And the radius is 50. 50 is actually 100 by 2. Okay, so 100 gets cancelled. Yes. So it is around 170. You know, root 169 is 13. You are supposed to remember this. Since root 169 is 13, so approximately root 170 can be written as 13 itself. So third option is the correct option. Then moving on to the next question. A block of mass m slides down the plane inclined at angle 30 degrees with the acceleration g by 4. The value of coefficient of kinetic friction will be. It's very simple, students. See here, this is the block. The block is sliding with a certain acceleration given as g by 4. Okay. If we draw the free body diagram, then the component of weight along the inclined plane is mg sine 30 degree, whereas the component of weight perpendicular to the plane is mg cos 30 degree, cos 30 degree being root 3 by 2. Then you have a normal reaction here and a frictional force here. Since the block is already sliding, the friction has to be kinetic friction, and this kinetic friction will be mu into n, mu k into n. So now if we apply Newton's second law, taking the downward direction along the plane as positive, then we can write net force is equal to mass into acceleration. So net force is mg by 2 minus kinetic friction, mass into acceleration. Acceleration is given as g by 4. Now kinetic friction is mu into n. Considering the equilibrium of the block perpendicular to the inclined plane, we can write n as normal reaction as mg root 3 by 2. So we have mg by 2 minus mu into mg root 3 by 2 is equal to m into g by 4. So let us cancel mg throughout, and 2 ones are 2 ones are 2 twos are. So finally we are left with root 3 mu is equal to 1 minus half, that is half. This root 3 goes below this. So finally we have mu as 1 upon 2 root 3. So second option is the correct option. Then moving on to the next question. A body of mass 0.4 kg takes 8 seconds to reach ground when dropped from a certain point P above the surface of Earth. The loss of potential energy in the last second of its fall is. So a ball is dropped from a certain height. It takes 8 seconds to come here. During the last second means prior to this, the time is 7 seconds. If we can find this height, then the required loss in potential energy will be mgh, where h is the height fallen by the object during the last second of its motion. So last second of its motion would actually mean the total height fallen during 8 seconds minus the height fallen during the 7 seconds. So this will be how much total height fallen? Half a into t square. Remember u is 0 and this will be half into a into t square. So the required height is half into a 8 square minus 7 square, which is equal to 5 into 8 plus 7 into 8 minus 7, so 5 into 15. So using this formula now, we can write potential energy loss is mass is point 4 can be written as 4 by 10, g acceleration due to gravity is 10, and h is 5 into 15. So this will be 4 into 5 into 5 into 3. So this is 100, so 300. So 300 joule is the answer. Then moving on to the next question. That's all in this video. Thank you for watching. Kindly subscribe to my channel and hit the like button. Thank you so much.